Alright, so what Planet Hunter Test is a website that has all the data from tests, which are generated light curves from the satellite itself. So what that also does, and what you can also do in theory, is search for exoplanets using this site. However, if you do come across a light curve and you want to investigate it further, you then are going to want to download a program called Miniconda, which is a coding software for just codes in general. And after you download Miniconda, you're going to want to install a program called Jupyter Notebook. And what Jupyter Notebook does is it's basically a program to allow you to extract and analyze the light curves. So, in a sense, while you're doing that, after if you found like an interesting candidate, for example, we'll just go right in and dive in. It's already 100%. It's already 100% complete. Although we're just gonna use some pointers here. That one doesn't look like a. That looks like a possible light curve right there. As you can see, the dips are here, here. I'm not sure about here, but I think here as well. So I'm going to add this to my collection of possible transits. Um, and will it give us, so magnitude is 11.89 star. The temperature is a little over that of our sun. The radius is about 1.6 solar radii, which isn't really a great ideal candidate, but there's something there. So I think we're gonna go done and talk, and I don't need to deal with that. So we'll check this out. So it is sector 64, which was just our last sector that we just got from last month. So we could check here and all that stuff here if we want to. We go to the master portal to check to see what. Let's see here. Okay, so let's go to our collection here, which it's not giving us our info when we need our info. Excuse me. So we need our info, and it's not giving us our tick number, which suggests that this is not a transit and possibly a simulated transit, which would make sense. Because if it is a simulated transit, that would explain why it's not showing a tick ID number. So, case closed. Because a normal tick ID transit number would have this. It would be like this. It would show tick ID 453, etc., whatever the number it is. Temperature would be that. Radii would be about 0.81. Magnitude 12. However, this does seem like a viable candidate because I am seeing a dip here. Ooh, that's a U shape. We'll have to take a crack at that. So what we're gonna do is we're gonna go in a masked archive. We're gonna look at this tick ID number. So we're gonna copy our tick ID number. We're gonna go into the masked archive and enter the target here. Take this out because I don't know why it does that. It just does it in general. So because I forgot to put tick. So tick 453472269, and it looks like a binary system, which is interesting. So that might explain the dip. So if it's a binary system, more than likely it's gonna show a larger dip, which in theory could be either a Jupiter-sized planet or it could just be a binary in general. But it definitely looks like a binary. It screams binary. but we won't know until we take a look at it. So we're gonna open up our Jupyter notebook. So we're gonna go here, go into our mini conda. Some reason our table is super wobbly, which is not a good sign. So, yeah. All right, now that we got our Jupyter notebook up, we're gonna pull up a new Python. We're gonna use a reference which I've made specifically solely for this tutorial. So we're gonna, I apologize, folks. My computer is not doing the necessary speed. Okay, so we got, okay, so for this tutorial, so it's a bit complicated, but it's straightforward. It's PLT. So and import let's drop the units as u. Oh, I completely forgot to do that. So now that we got that set, it's gonna run through, but for some reason matplotlib, I have to keep copying this section. I don't know what its deal is with matplotlib, but it just it's because I forgot the P. That makes sense. Okay. I always forget the P for some reason. Okay. So it was my fault. So hashtag search for your target using its tick ID. So in a sense, for the tick, you typically want to search TIC. So we're going back here, 435, whatever this tick ID is. And we're gonna go that, bada bing, bada boom, and then search. Oh, whoops! I did not mean that. So, okay, so we go back here. Check the availability of the data for this target. Available data all equals lk.search light curve. Oh, not for some reason I keep thinking it's that. Anyways, so basically what this one does, it will search all available information related for this specific target based off of what is available out there, like the MAST portal. So basically, it just goes through the entire thing, which should work. Question is, it's not worth doing the hashtag, so hashtag. Okay, so check the availability data for this mission target. For some reason, it is not working, which I now see why. So, there we go. Okay, so it was supposed to highlight in blue, and for some reason, ours did not highlight in blue. So, we got that. Okay, so next. So next, what we want to do is click available data all. So it's got all our data here, which we have sector 37 and sector 64, which It was a couple of years ago. Wow. So Sector 37 is showing promising results. So if it is an exoplanet candidate, then we have two sectors to check our light curve and run our light curve analysis. So, nextly, what this is gonna do, you're gonna do select multiple sectors based on the available data above, and then collect LC. So select sectors. Download underscore all, and then which for some reason is not working. Which I don't see why it's doing that. Sectors. I see where I screwed up. I meant to copy this line. Instead of... Okay, so then what this command is going to do is download and illustrate multiple sectors of data. So basically all the data combined from all the missions that Tess has done is going to combine all of them, drop them down, and plot them in a chart, basically. So Control Enter, then press B, and then we'll see that slot, which did not register my period, which is stupid. Okay, so here we go. So we got faint star. Faint star. That's interesting. So we apparently got faint star. Target. So this is what the data looks like. It's a handful. So the data looks like this. When it looks like this, it doesn't look organized. It looks like that. So the next step would be to stitch basically the different sectors. So I'm just gonna copy and paste this command. So this is what it does. You Control Enter. Ignore the error warning. So the error warning is kind of common with this. So collect LC.plot, color, whatever. I think we're gonna do red this time because that's what the color was showing us. So, okay, there's our data. So, it's showing. Okay, what we need to do now is we need to highlight this sector, which is sector 64. Unfortunately, I see the dip here at 3050. Although it might not, it just looks scattered. Like there's just too much scattered noise. Shit. So, I'm gonna highlight this section here because it is showing promising results. Because I can see it here, and I can see it faintly here. However, it could be nothing. So, we're gonna mask our light curves. We're just gonna copy this command because this command takes forever to. So we're gonna go from 3052 to 3049, and we'll see what this does. And it looks like a, wow, that does look like a dip. Interesting. But in here it's showing it's scattered. Interesting. So there's a few hypotheses I can make based off of what I see. One being that I was right and this could be a potential binary star because the noise it's producing is way too much. So as you can see in this section right there, it's just scattered. It's scattered heavily, so and it's so noisy. Like you can see here, it shows a dip. And it looks like a 1% dip. I want to make sure. So 0.99. So we're to take 1.0 divided by 0.99, and it's showing us a 1.01 dip, which typically sounds like it's scattered. So now what we're going to do is I'm going to block these spam callers. So give me a second. I'm just putting my phone on Do Not Disturb so that way the spam callers can just screw off. Here we use the Boxley square method. So basically it's a periodogram with the periodic signals and calculate the exoplanet's period. So this is the fun part. We're gonna hit control. So basically what this does is gonna import the stuff that we imported earlier. And it's gonna do all that with the BLS power. And we are getting a strong signal. Check that out. We're getting a strong signal. Wow. And that's not looking like it's scattered. Okay. So did we find a reliable transit signal? We'll find out. So it's gonna fold so this next command I'm gonna enter is gonna fold the light curve based on the period of the epoch, which should help us hashtag after transit on phase 0. So folded underscore LC equals mast underscore LC dot fold ELS dot period at max power at max power epoch time equals ELS dot transit underscore time at max power. Should work. Then folded underscore LC dot plot. So folded LC dot scatter S equals 3. If it doesn't work, I can just always copy and paste it. X and Y. So yeah, keep that up. Yeah, screw it. We're just copying the rest of this. I don't care. Okay, so here goes nothing. And it looks like just scattered noise. Which is to be... Which is to be expected. If it's... But... We'll figure this out. Like I said, it didn't fold properly, it didn't show a transit. So, unfortunately, this is not a reliable candidate. So what we would do is scratch this, go back to go back to Planet Hunter's tests, and look for another signal. So, yeah, that's what we do for Exoplanet Watch. You can, if you found this tutorial helpful in any way, consider subscribing. It helps out the channel and it's free. So, we're on the road to 50 subscribers, and we're just a brand new channel trying to make it. So, we're gonna be coming back out with another video on Monday. So yeah, for Monday's video, we're doing another Kerbal Space Program video. So stay tuned for that, and see you next time. And I'll catch you on the flip side.